In this lesson, we're going to discuss scientific notation. And to do that, we're going to use this number line to kind of talk about how to deal with exponents that are positive and negative, because that's where I see students mess up the most. So let's get right into it. I've established all the number line as 0, 1, 2, and 3 to give you some relationship here. And the first thing I'm going to pull up that's in scientific notation is going to be 1 times 10 to the first power. Okay. I think most people understand that this is just the value of 10, so maybe somewhere around here-ish, okay? Next one that we're going to put up is 1 times 10 to the second power. Okay, now remember, that's going up to the second power, so it's exponential. Sometimes my students think that this is actually 20, okay? But hopefully you know that 1 times 10 to the second power is going to be 100. So this is going to go off of our number line because that number is so large, okay? Now, when it gets to the negative exponents, this is where sometimes I have students struggle. So this is 1 times 10 to the negative first power, and I see some students putting this way over here, and that is incorrect, okay? This is not equal to negative 10, okay? In fact, okay, if you think about this, okay, as far as moving your decimal place, remember if the exponent is negative, the only thing that means is that it's a small number. So really, if I was to open up this space between 0 and 1, this would be placed right about here because this is actually worth 0.1. Okay, we're going to talk about why that is here in a second. Likewise, if I have 1 times 10 to the negative 2, okay, this is not negative 100, okay, and a lot of times students think it is, but it's really just a smaller number. Instead of 0.1, it's going to be 0.01, okay, so that would be placed even closer to the 0. And the two things that I usually tell my students to help them understand all of this is really pay attention to the exponent, okay. So the first thing that we're going to talk about is what happens when the exponent is positive. Okay, so if the exponent is positive, I say that's equal to a big number. And then obviously the opposite is true as well. If we have a negative exponent, that means it's going to be a small number. So let me give you a couple examples of this. Okay, let's say I had the number 3.5 times 10 to the third power. The first thing I'm going to do is I'm going to look at that exponent, and it says, hey, that's a positive exponent, so I got to make this a bigger number. Okay. The reason why I'm trying to teach it this way is because I want you to think about this conceptually, and I don't want you to learn this from a memorization point of view. Like some teachers will say, hey, if it's a positive exponent, move the decimal point in this particular direction. And I don't want to teach that way. I want you to think of positive exponents as big numbers, and then you logically figure out which way to move the decimal point. So if I'm trying to make this a big number because this is a positive exponent, I know I need to move the decimal place over to the right to make it larger. And the exponent tells you how many places, okay? So if I move that decimal place over 1, 2, 3, you're going to end up with 2 zeros here because the decimal place has been moved over 1, 2, 3 places, okay? And if I gave you a number of like 2.1 times 10 to the negative 2, same thought process. I'm looking at the exponent. It's a negative exponent, which means it's a small number. So you know which way to move this decimal point. To make this a small number, you're going to move it to the left 2 places. And if you do that, you get 0.021 because the decimal place has been moved over 2 places. So the exponent tells you how many places you need to move it over. The positive and negative really kind of tell you what direction, okay? And then you can do this in reverse as well. Like if you have this number of, 3,800,000, and you know you need to put this into scientific notation, I want to remind you guys, you always put it between the first two numbers, okay? So I get 3.8, okay? And this is a really big number, okay? So I know the exponent is going to be positive, but by how many places? 1, 2, 3, 4, 5, 6 places. Likewise, if I have a really small number, and I have to put this into scientific notation, remember the decimal point goes between the first two numbers, okay? And this decimal place is going to be moved over 1, 2, 3, 4. And since it's a small number, it's going to be -4. So I just want you to connect this idea that positive exponents mean big numbers and negative exponents mean small numbers when dealing with scientific notation.